Hello, pre-calculus students, and welcome to our continuing lesson on rational zeros theorem and factoring higher order polynomials. I haven't actually introduced the rational zeros theorem yet, so let's just start with a review problem from what we see in the last section. Okay, so it says just to simply divide this. Okay, and a few things that we can check here. We can see that for the divisor, this term here has a power of 1 and a coefficient of 1. So that means that we can use synthetic division. So that's always a really nice thing to know and to keep in mind, is that when your divisor is a binomial with a power of 1, coefficient of 1, you can use synthetic division. Let me emphasize that too. This has to be a binomial here. In other words, it's got two terms, x and minus 1, or usually whatever that constant is. Okay. Well, so let's use synthetic division here. And we can set this up as follows. We take the divisor, we put the 1 in here, and then we list out all of these coefficients. 2, -1. Now, one thing that's important to note here is that we do not have x to the third. Okay, so I should really write this. This is really 2x to the fifth, -1x to the fourth. We do not have an x to the third here, so we actually still need to writing in a 0 as a placeholder. Okay, so this is kind of a tricky subtlety to this. So we need to use 0 placeholders when necessary. So we need to have all the powers here. Then this is 3x squared, -1x, and then 5 out here is our constant. So I'll write this out. This is 3x squared, -1x to the first, 5x to the 0. So all of the powers have to be accounted for. Okay, and then we can do our division. Bring down the 2, multiply, add these two, multiply 1 times 1, add 0 plus 1 is 1, 1 times 1 is 1, 3 plus 1 is 4, 4 times 1 is 4, -1 plus 4 is 3, 3 times 1 is 3, 5 plus 3 is 8. Okay. And just as a reminder, all of these powers here decrease by 1. So this is x to the fourth, x to the third, x to the second, x to the first, x to the 0th, and this right here is our remainder. Okay. So now our final answer is 2x to the fourth plus x to the third plus x squared plus 4x plus 3, remainder 8. Okay, and this isn't really something that's standard here, this R8. So what we usually do with the remainder is we just rewrite it with the divisor as a fraction. So let me show you better here what I mean. Plus 3 plus 8 over x minus 1. Okay? So this second form right here, this is called fraction form. And what this does is it puts the remainder over the divisor. And this is kind of like in elementary school when you did something like, if you did 31 divided by 8, you would get 3 remainder 7. So your answer there is really 3 plus 3 sevenths, or 3 and 7 eighths. What am I saying? 3 7/8. Okay, so that's kind of the same thing that we're doing here, but instead of having a raw number, we have a algebraic expression right there. Okay, so there you have it. This is kind of a review, and the main thing that I wanted to emphasize here is this point right here, when you're going to need to use a placeholder whenever a power is not listed in the original problem. Okay. I'm going to end this video here. I'm going to move on with another video that kind of built up on the same idea, and it's really just review again from the last set of videos.